In this problem, I've got a A36 steel column. Okay, it's 4 meters long, pinned at both ends, has the cross section shown. Okay, and I want to find the critical load so that it does not buckle. Okay, so the critical load, P critical, the equation is, and again, you can check your book if you want to see where this comes from, but it's pi squared EI over KL squared. Okay, so the most complicated thing that we've got to go through here is probably finding I. So we'll go ahead and find I on this guy. That's the moment of inertia of the cross-sectional area. And the way that we're going to do I is we're going to take the middle horizontal piece and add the top and bottom smaller rectangles. Okay, so it'll be 1/12 BH cubed, where B is 60 millimeters and H is 10 millimeters. Okay, and then I'm going to have 2 of these other rectangles here, which is going to be 1/12 BH cubed, which is going to be 10 millimeters, and then 25 millimeters. Okay, and then of course I've got parallel axis theorem that I need to add on to that, which is going to be the area, which is 10 by 25. And then the distance, which is going to be, goes from 5 and then 12.5, so 17.5 away. And again, there's 2 of those. We take that again. So again, to get to the center between the neutral axis and that, again, I go up 5 to the bottom of that, plus the 12.5 to get to the center. That's where the 17.5 comes from. From that, I find that the moment of inertia of this entire area is 184.167 times 10 to the -9, and again that'll be meters to the 4th. Okay, so I've got that I. Everything else is pretty straightforward in my critical load equation. Okay, so let's go ahead and start plugging things in. So I've got pi squared. Okay, E for A36 steel, you look that up, it's 200 gigapascals. Okay, so you find that in the back of the book. Okay, I we just calculated is 184.167 times 10 to the -9. Okay, divided by K. Now it's pinned at both ends. Okay, so K is going to be 1. Okay, that's the effective length, or the constant that goes in front to find the effective length. So for pin to pin, which is the standard one, is going to be 1, and then L will be 4 meters. Okay, and then I've got to square that whole thing. From that, I can find that my critical load is 22.7 kilonewtons. Okay, so again, pretty straightforward. Okay, probably that. Well, there's no real tough part. It's just kind of a plug and chug sort of situation here. Again, the effective length based on what kind of loading, or what kind of boundary conditions you have. So I've pinned on this one, so K is going to be equal to 1. There's a chart in your book to find where those K's are. But once you get all that stuff, you just plug it in and move on.